Okay, so 4 problems today that you were assigned in the Read and Got It. First one here, graphing a function rule. This is where we talk about the whole domain range idea again. So the domain, the x's, right? You pick those. And then the output, the ranges, right? That'll be the y over here, are what you get, right? When you enter this, your inputs into this function. And then we just graph them. Please remember, x comes first, and that's the horizontal axis. Y is the second number, and that's the vertical axis. So when you graph something, so let's say we graph 0, 1, we go nowhere on the x and go straight up 1 on the y. And again, a series of points, then you play connect the dots, as long as it's not a discrete function. Got it on the next, the actual got it on the next slide. Okay, so your got it was what is the graph of the function rule y equals 1/2 x minus 1. And again, you get to pick the inputs. Pick ones that make sense, ones that are easy to work. For instance, you notice here 1/2, right? 1/2 multiplies by 2 very nicely, and gives you some nice numbers to deal with. Don't pick things like 0.3, right? Things that are going to make this a lot tougher. So as we noted, we're going to pick -2, 0, and 2, and this is really just plug and chug. So y equals 1/2 times -2 minus 1. Well, 1/2 times 2, right, that's -1, right, minus 1, which is -2. So I get -2. And when I plug in 0, I'm going to get -1. And same thing, if I plug in 2, I'm going to get 0. So then we just go back and we graph those. And remember, when we graph, the x comes first, right, and then the y. So I start here and I graph -2, -2, that's down here. And then I graph 0, -1, that's down here. And then I graph 2, 0, and that's over here. Now I do expect, obviously, that you get the math part, right? The algebra is pretty straightforward, pretty easy stuff. There you go, there's got it 1. Alrighty, so our second one here is, it gives us this function right here, right? And it talks about the cubic feet of concrete affecting the weight. C here, the cubic feet of concrete, that is your x, that is your input. And we put that over here. The output, W, right, over here, that is the weight of the truck. So notice it's 140, or 146 rather, times the number of cubic feet plus the 30,000. Now, here's the thing. I bet you can't guess what that 30,000 is. Notice that's a constant in there, right? That's like that price to get in the door thing, or price to get in the cab kind of thing. That is the weight of the truck itself. Notice here, 146, 0 feet of concrete yields that same 30,000. So that's the weight of the truck. Not entirely like you have to know that to understand the problem, but it's kind of important to kind of understand the function and how it works. So here, no concrete, 30,000 pounds. If you put in 50 feet of concrete, right, cubic feet of concrete I should say, we get so that 50 times 146. So that must be the weight of, right, each cubic foot of concrete. Gives us 37,300, so on and so forth, right? Pick numbers that are easy to multiply. And go back and we graph it. Notice the truck starts out at 30,000 pounds as we go to graph it, because that is the weight with nothing in it. And then 50 feet of concrete, cubic feet rather, 100 cubic feet of concrete, so on and so forth. So there is a real-world application to this, and I imagine there's probably a maximum, amount in something like this. So, you drive across roads. Some roads can't take the weight, maybe, that other roads can. So they go, oh, if we're going to drive on this road to this guy's house, we can only put in maybe 100 cubic feet because the road will only take 45,000 pounds. Something like that. So it's a real-world application. All right, got it on the next slide. Okay, similar to the last problem. This one gives us a function right here, W, oops, need to use, there we go, W equals 8G plus 700, represents the total weight in pounds of a spa that contains G gallons of water. So input, again, is G, that's like our X. Goes down here. Oh, and something, too, it's real important you should note is labeling. When you graph for me on quizzes and tests, you'd better label so I know what it means. And please make sure input goes X, output is Y. That's really important. Alrighty, so it says, so what's a reasonable graph, right? Given the capacity is 250 gallons. So that means you can't go over 250 gallons. You put in 251, it goes over the edges. And then B, what is the weight of the spa? Well, let's talk about that one first. The weight of the spa, obviously, if there's 0G, right, 0 gallons of water, is 700. So if I were to generate a table, right, we're going to call it G and W instead of X and Y. Remembering, again, G, though, is like the X, and W is like the Y. And if I put in 0, I'm going to get 700. So no water means that I have, that's right here, 700, right? 700 pounds of weight. Alrighty, and again, you get to pick the inputs. So if you put in, if you put in 1, right, you're going to get 708. By the way, from this, kind of a side note, can you figure out how much a gallon of water weighs? Yes, it is 8 pounds for a gallon of water. And I only know that because of the trebuchet I've told you about that we've built with our sons. So, anyway, so again, you put in 100, right, and it climbs on up. And you put in 200. So, again, doing the math, plug and chug here. And then a nice straight graph here. And again, it's 700 pounds when G is 0, so W, 700 pounds, is the empty weight. And if you need to pause me to look over your graph, make sure it looks the same, that's just fine. Oh, so yeah, anyway, I forgot to write it and I said it. But again, put in 100 and you get out 1,500 pounds. So 100, 1,500. So again, the graph just continues up there. And again, you get to choose the inputs. Okay, so here we have that discussion we had yesterday regarding continuous and discrete. And again, continuous is when a graph is able to be a line. Discrete is when it has to be dots because it doesn't make sense otherwise. So here we have this first function, W equals 16M, where again W is the weight of the cheese, that's the output, and M is the ounces of milk, gallons rather of milk put into there, and how much, again, the weight of the cheese that comes out. So here, put in 0, you're going to get 0, right? 1, you get 16, 2, 32. Now, the reason that this one is a continuous function is that you could literally put in 1.1 gallons, or you could put in half a cup, or you could put in, any number and get the weight back out of it. And it's going to, again, follow this constant function rule here. But again, continuous because you could literally put in any amount. Now, the discrete comes out because we sell them at only as whole wheels. Now, if you sold them individual slices or an ounce or whatever here or there, then it could be a continuous function. But this guy right here, right, he sells them, kind of looks like that Burl Ives or something there. But anyway, he only sells whole wheels of cheese. So 1 wheel, right, he makes $9. 2 wheels, he makes $18. 3 wheels, and so on and so forth. And again, with that function, A equals 9N, where A is the dollar that he makes, and 9 times N, that's the selling each wheel, so $9 each wheel. But again, it has to be discrete because he only sells whole wheels. He never sells parts of wheels. So again, continuous and discrete. And you got to think when, what that makes situation that makes sense. Like when we're talking about people, right? Then you're probably going to have discrete because you don't bring in parts of people. That's disgusting. Okay, so here's our discussion we had over continuous and discrete. And again, continuous, obviously continuous line. Discrete means individual dots. The first one here, got it 3A. The amount of water, W, in a waiting pool in gallons depends on the amount of time, T, in minutes, the waiting pool has been filling. As related to this function, W equals 3T, right? So for each for each 1 minute, you're putting in 3 gallons is the idea. This is going to have to be continuous because time is continuous. You don't jump from minute to minute to minute to minute. You have, seconds, milliseconds, right? 30 seconds, whatever. It keeps going continuously as it fills up. And each bit of time puts in a little more water. Now the second one, the cost, C, for baseball tickets in dollars, depends on the number, N, of tickets bought, as related to the function rule here. 16, or C, rather, equals 16N. So our input, right, N, number of people, times 16, so $16 a ticket. You have to buy whole tickets. You can't buy part of a ticket, like, oh, we're just going to let in Grandpa's foot, right? And I'd like to buy 1/10 of a ticket for Grandpa's foot. Now, is that gross, but it's also weird. You have to buy whole tickets. All right, so that one makes it discrete. Okay, so we're talking about graphing nonlinear functions. Now, this means functions that are not a single straight line. Doesn't mean combinations of line like this one here, right? Or, obviously it means continuous curvy ones like this. So, currently we're just working on the whole plug and chug method. We will talk later about, where these different pieces come from, how they look, why it curves, things like that. But we're still doing this the plug and chug method for this part. So, and again, you're going to pick numbers. You get to pick the inputs that make sense. So if we take a look here, y equals the absolute value of x minus 4. So obviously, you can see the work done here. Plug in your -4. Absent -4 is 4. 4 minus 4 is 0. So I get -4, 0 down here. Plug in a -2, right? Absolute value of -2 is 2. Minus 4 is -2. Again, order pair -2, 2. So -2, 2. Here it is. So on and so forth. Pick ones that make sense, ones that are easy to multiply, ones that are easy to add and subtract. And you can see the table generated here. It's going to create this. Second one, so once we start squaring, we lose in any piece of a line, right? It starts becoming curvy. If we cube it, right, or to the 4th power, whatever, it's all going to change a little bit, and we'll talk about what those differences are later. But right now, it's still just plug and chug. Pick numbers that are easy to work with, though, right? Ones that are easy to square, easy to add and subtract. So -2 going in here. -2 squared is 4. 4 plus 1 is 5. So -2, 5, so on and so forth. Being up here, and you just plug them and understand when it's squared or cubed or things like this that it's going to be curving, and we'll spend more time on that later. So these are non-linear functions. Okay, so you got it here. What is the graph of the function rule? Y equals x cubed plus 1. So I went ahead and picked some points. Again, ones that are going to be easy to work with. And let's just start at the top here. So we have y equals -2. Don't forget to cube the negative sign, plus 1. Well, -2 times -2 times -2 is -8. So y equals -8 plus 1. So y equals -7. Right? And you plug in 1, so go ahead and do the work there. -1, 0, 1, 2, 3. And let's see what you get. Okay, so there we go. Again, a little plugging and chugging. And we go back and we go ahead and graph them. So -2, -7. Right, so we start at the center here, and I'm going to use my laser pointer. 0, right, moving over -2, and all the way down to -7. That's going to be down here. And then -1, 0. So -1, 0, that's right there where it's going to cross perfectly. And then we've got 0, 1 up here. And we'll talk, some of these have special names too, and we'll talk about that later on too. So 1, 2 up here. And 2, 9 going to be up off the chart, right? And 3, 28 certainly going to be off the chart. So there you go. Again, recognizing when I cube or square things like that, that it's not straight lines connecting them. Make a nice curve that goes between and connects them all.